All right, welcome everyone. My name is Billy Autrey. I am the head of professional services at EngFlow, a very fledgling group. It's mostly just me. um, I have a history in professional services. I used to be a Scala consultant, so if you know a lot about Scala, then you can talk to me. There are dozens of us, you know. Uh, but other than that, I spent a lot of time as a Bazel person. I actually worked for a crypto company for a while. They hired me as a Scala person, but then they said, actually, we want you to be a Bazel person, and I had no idea what the heck is Bazel, right? And so I was hired in as an expert, so I decided I needed to become an expert. I became the principal developer productivity engineer for this crypto company for a while, made my way into EngFlow. And when you're consulting, you often find yourself wanting to know, like on day one, okay, what do I need to know to actually get my job done? You ask yourself that question over and over and over again. And this course is sort of the Bazel version of that, right? I wanted to know, okay, if I were starting my job day one at some place and I didn't know anything about Bazel, what do I need to know to actually like start to become a Bazel expert? What are the blocks? What are the pieces I need to do? What is my day-to-day like? And so this course is supposed to kind of answer some of those questions. Um, well, before I go on to all that, I will say that this is part of a world tour that we're doing of events. We're doing this exact training in a few other places. So if you didn't catch everything, or you know people in some of these other places, let them know the future dates are coming, and we'll do similar things. We're not doing this exact thing everywhere. You'll have to check meetup.build to see all of the events, but one of my cohorts, Mike Bland, is doing his presentation on Bazel mod. Jay Conrad, who you might know from Gazelle, is doing a presentation about writing rules. And so there's a whole like build scale investigate world series. You can check out the website to see that. And then also another invitation. Tomorrow night after the convention, we are doing a game night. That QR code should take you to the registration page, which is on meetup.build. So feel free to come, play pool, cornhole. We have a board game that we created. You can come play that and, investigates real build problems. This is a disclaimer. This is just letting you know that there is some code in here. Most of this code is open source, Apache. That means please don't use this for commercial reasons. Also, there's no liability. There's no warranties on any of this. But also, there will be a code repository you'll be working with. This is a hands-on. This is not just me presenting for several hours. I plan to spend time back and forth. I'll go into that a little more in a second. But that code also is open for the moment. I know that there was a registration form that some of you were sent to say, give me your GitHub ID. That's to give people access to the full repo. But for the purpose of this demo, there's so many of you, it was going to be too hard to do. So I just opened it for today. So the repository we'll be working with, you'll be able to see on GitHub. I'll show you where in a minute. Okay, so this is my spiel earlier about learning what you need to do to know on day one to be a productivity expert. That is the full day course, right? There's a full day of content. It's actually probably more than a day, but I cram it into about 8 hours, and people get kind of tough with it. It's pretty hard to just follow. I actually these days I've been splitting it into 2 4-hour days. That works pretty well, especially with remote. But for these purposes, we don't even have the full 4 hours for this. So what I've done is I've selected some topics. So just to go over the agenda of the kind of topics we're going to talk about today, I'm going to talk briefly about managing the workspace. This is just going to be like a very gentle introduction into Bazel mod and how to touch it. If you've never touched Bazel mod, this will be a great introduction to just get your feet wet and understand what the heck it is. Module 2 is normally Starlark and macros. I introduce the Starlark language. We write a little code, but I'm going to skip all of the Starlark part and just jump straight into macros. We're going to there's some Starlark code that was written for the other exercises. You're going to write a macro to integrate that. And we'll talk a bit about hot takes on macros. There's a section on default rules and configurations. So this is things that are already built into Bazel. Things like rules sh is not really. I mean, it's in the process of being taken out. But we cover a little bit about rules sh. We cover gen rule, things like that. And then also configurations is important, just in general to queue up queries. We talk about A query and C query. So if you know anything about C query already, you know why we're covering configurations. That's I guess a spoiler for you. Uh, Section 5 is a whole section on platforms and tool chains. That is way too much content to cover in a demo, so I'm not going to cover it here. If you want, there is a full course. You can ask me about it. I can tell you a little bit about what's in there. But what I try to do is like attack at a very core level. What is a platform? What is a tool chain? And the answer is probably a lot simpler than you realize. And so that's what that section is about. Sorry, we can't cover it today, but please come find me if you want to know more about it. Section 6 is about Bazel architecture and sandboxes. So we just talk about, in general, how the Bazel daemon works, how certain pieces work, and we're going to do a little exercise to kind of explore sandboxes. And then finally, the last section is on debugging builds. We talk specifically about profiles, and we attack a hermeticity issue. So cool. So that's a bit of the agenda for you. Logistics. This is normally what I do, an hour for lunch, depending on when it's scheduled. We're not going to break for lunch because we just had lunch. I'm sorry that you're in a dark, cozy, warm room right after lunch listening to me, but here we are. What I'm going to do is I'm going to talk to you for about 15 minutes, 20 minutes, something like that. The sections vary in length, but I'm going to talk at you for a while. I'll take questions, of course. Raise your hand if you have questions during, and then we'll spend some time hands-on. People learn different ways, and most of us in here are probably engineers or budding engineers or interested in engineering. And so I would say that most of us like to learn with a mix of, reading and hearing and hands-on. And so I try to give a mix of all of those things here. So there's going to be hands-on where you go to a Git repository, you run a code space on GitHub, so you don't have to run it on your laptop, and then you can manipulate the code in VS Code in the browser and go from there. Labs are choose your own level of engagement. The idea here is that there's you'll see different drop-down sections of varying levels of hints. There's the instructions, which are very vague. So if you're a Bazel expert, try it with just the instructions and see how far you get. And then there's the hints, which is okay, I need a little bit of help to bail me out. And then there's a step-by-step, which details, okay, these are the pieces you need to touch, and here's what you need to write. And then there's also I'm totally lost, help me. And so there's a final section, which is just give me the answer code, and it's there. But I'll talk more about the lab setup when we get closer to that time. This is a link to the slides. So I have the slides exported as a PDF, the exact slides that you're looking at. I think the QR code for the meetup is not there, but you can download this. It has the same disclaimers and everything. But yeah, feel free to download it and follow along. I guess a pro tip for you, the way that I look at exercises is that anything that you do in an exercise, you should be able to look back at the slides for that section and get the answer to what you're trying to do in those slides. So it's helpful to have those on hand. Any questions about all that? That was all the dotting of the I's and crossing of the T's. No? All right. I got some coffee in me. Let's go. So this section on managing the workspace, I usually talk for a little while about the layout of the file structure. It's kind of interesting to look at, but that section is not covered here. We're just going to jump right into workspaces and Bazel mod. So the problem with workspace files, if you've ever worked with a workspace file in Bazel, you know how much of a headache they can be for really complex monorepos. They can get really, really, really big. There's a whole bunch of extra code in there. The code has to be in the right order. Diamond dependencies can happen, and so you have all sorts of crazy situations that happen. So workspace files can be really tricky. They're almost like, you can kind of think of them as brittle as shell scripts. It's just a lot to sort of wrangle. And workspace files can be just really cumbersome. They're the bane of my existence when I was doing developer productivity at a crypto company. And so that is actually what Bazel mod is supposed to be fixing for the most part. It is, in short, an easier, gentler way to manage external dependencies. So if you've ever worked with workspace files, or I guess if you haven't, what it normally looks like is you have an HTTP import or an HTTP archive where you download a zip file or something like that, and then Bazel will unzip it, and then you have to tell Bazel, hey, in that thing that you just got, that repo, go pull this rule out and then run it, and then go pull this rule and run it. So you're manually installing all the pieces that you download in your workspace file. Bazel mod takes care of that for you. It has a central registry here, the registry.bazel.build. That's called BCR for short. So if you hear someone say BCR, that's the Bazel Central Repository. So you don't have to tell it where to go. It will go to VCR. You don't have to tell it how to install the thing because Bazel mod runs the pre-canned install script to do it. And you don't have to worry about the order because Bazel mod will calculate the order for you and figure out the dependency tree and then do it in the right order. And so it's essentially a way to sort of shift some of that responsibility over to rule maintainers and repo maintainers so that it makes it a nicer, easier experience for you to actually do things, to manage your workspace. The files that are involved in Bazel mod are pretty straightforward. There's a module.bazel file where you put your dependencies, and then there's a lock file that has like the calculated list of all of the dependencies that sort of come out of Bazel mod. So, if you just import one thing and then you look at your lock file, you might see a bunch of stuff. Well, that's all the transitive dependencies for your Bazel mod dependency. So you might be asking yourself, how easy is it to use Bazel mod? What does it look like? It just looks like that. It's pretty straightforward. It's actually not that straightforward, but naively, if you had a very simple repository and you had a very simple setup and you didn't have like a whole lot of external dependencies, you could just do this and it would sort of work. This single invocation, this rule, or I guess instantiation, will go to BCR and will go look for rules ABC version 009, download it, run its install script, boom, you're done. There's like 30 lines of CRUD in your workspace that are no longer have to deal with. So that's a nutshell what Bazel mod is supposed to help you with. But we live in the real world, right? Not everything is so clean. So let's say, for instance, I'm just going to pull a random example out of my head. This didn't come from experience or anything. But let's say, for instance, that gRPC is on BCR, and the version you pull down doesn't actually work if you try to generate C++ gRPC code. Let's just say it breaks for some unknown reason, and you go and look it up, you Google the error, and you can see in the gRPC code base, we're not going to fix this, we're not supporting Bazel mod yet, right? What do you do in that situation? Let's say that when you Google it, you also see somebody says, hey, I did this patch, and this fixes the rule set, so all you have to do is patch your own repository and do this. Well, it sounds great and all, but I don't want to have to download a whole thing, host it somewhere else, and then patch it, and then have to worry about all this like back and forth of managing my patch and updating it if something is broken. So in the real world, I might have to deal with a repository that's not maintained, or I might have to just do a simple patch to get me down the road, or maybe I found a bug that's only hitting my code base and I opened a bug report for it, but I know how to fix it, and I just want to fix it today until the new version comes out. So how do you do that? There's a few tools in Bazel mod that will help you with this. The first is called single version override. That is, it's kind of a Swiss Army knife. It lets you do single in-place overrides. If you want to add a patch file, you can give it like the location of the patch file, and it will apply that patch file on top of your dependency that you download from BCR. You can also pin versions if you want to pin something and make sure that it's absolutely on this particular version and everything under it is the same version. If you want to use an alternate registry, you can tell single version override, hey, I want you to download this, but not from BCR. I want you to download it from my Artifactory or my something else. So single version override is kind of a nice way to do some very simple overrides to Bazel deps. If you want more specific overrides, there's also archive override and git override. So if you have a zip file on your hard drive somewhere, then you can use archive override to point it at that. And then if you have a git repository somewhere and you have a SHA that has your fix, then you can just point it at that instead. So there's other ways to sort of do this if you want to kind of have more control than just the paved path. This is what a single version override looks like. The idea here, the syntax is for module name, you give it the name of the Bazel dep that you pulled in. So this, Bazel dep name is some Bazel dep that I pulled down. Patch strip, you don't have to have this, but that allows you to like strip prefixes on your directories in case your patch that applies to the Git repository doesn't actually match what's in the workspace for you. So that can be helpful sometimes if you have a directory clash. And then the patches is a list of labels that you apply to that particular Bazel dep. Any questions on that so far? You can do it for anything. Like for instance, in my totally not real world scenario, it was real world of gRPC. I had to patch gRPC to get it to work, And so I pulled the BCR public version, and then I applied my patch on top of it, and then it got everything to compile. So you can do it for private or public, or you can use other mechanisms to get private repos as well. Yeah. The patch itself. Yeah, the patch itself needs to be in your workspace somewhere. Like it's a label, so if I guess if you had a repository that you pulled in somewhere and it was in scope, then you could refer to a label that was a patch file that was in a different repo if you wanted. I,
I tried that recently. It didn't really work.
oh, it didn't really
I
work.
think it's also probably because by the time it's processing it, specifically in Bazel mod,
Mhm.
I did this at once.
Oh, okay.
But in Bazel mod, I think it's probably that repository didn't exist yet because it was processing it all together.
Oh,
So,
yeah. That makes sense. Yeah.
doesn't actually, it did have to be in the local workspace.
Okay. Well, that I learned that today. I did not know that. Uh, okay. So let's talk about extensions and repos. Full disclosure: I drove here last night because of the American government's flight situation, and so I'm a little tired. But we'll muddle through this. Extensions and repositories. Extensions allow you to configure extensions for modules. So the way you can think about this is, let's say that I am pulling in rules Rust, for instance. In Rust, you usually use cargo to download dependencies, or if you're in Java world, you use Maven or Ivy to pull dependencies. But you don't necessarily need Bazel to know everything about that. And in fact, you want Bazel to be able to defer external repository management to rules authors, so that rules Rust can feel free to use cargo or maybe its own new thing that that's not cargo, or you can use different Python repositories. You could use VC instead of pip or whatever, right? So use extension is a mechanism by which you can extend Bazel and tell it more about how to do things specific, and it's usually specifically used for external repository management, so cargo, Maven, things like that. And then use repo, the declares repos used by use extension. So the kind of setup that you typically see is you declare, okay, I'm going to use pip, and here's all the stuff about pip in use extension. And then you call use repo, and it will actually go and fetch pip things. Yeah, so that's a little bit of a preview between extensions and repositories. I guess I would say in general, you're probably going to use both if you're using Bazel mod to pull in dependencies from something. The other thing that extensions and repositories do is it allows Bazel to kind of reason about daemon dependencies. So if you hate this example, you can blame Google. This is straight out of their documentation. So the idea here is that that D depends on B and C depends on A. So if A, B, and C have different Maven dependencies that are pulled in via extensions, then because they have extensions, that allows Bazel to be able to reason about the dependency path and the daemon dependencies and pick the right version that will end up in version D down at the end. So that's the straightforward, the nickel tour of daemon dependency resolution and extensions. Actually, if you watch the recording, I believe that Mike Bland does a much more in-depth dive on extensions and repositories. And so if you really want to understand this at a deep level and understand like some of the daemon dependency resolution for Bazel mod and for extensions, he goes over that. And he's got like a really great example. So here's an example. I already sort of gave this away, but if you are going to configure usage of pip and specify what requirement file to use for pip, you would put all those attributes in a use extension, and then for use repo, you would execute extensions to pull remote dependencies. So that's what that's all about. And here's what it looks like in practice, right? So in this case, what we're doing is we're calling use extension. We're pulled in rules Python, and we're saying there's a pip.bzl somewhere that's an extension that tells me how to use pip. I call, so that creates a new like object that's my extension, and then I can call pip.parse on that extension, and it will parse that lock file, and then use repo tells it to, hey, actually go and use the thing. Configuring Python. So when The fun thing about Bazel mod and rules is that sometimes the rules authors also have other requirements that they sort of build on top of everything. So not everything is just super friendly. And so this is, I guess, a hint for you in the exercise that's about to come up. If you're configuring Python, you have to also in a build file somewhere have a declaration for compile pip requirements that will actually take your requirements in file and generate a lock file out of it. And so you have to declare this target, and then you actually have to call it to generate the log file, and then after that your build will work for Python. But this is like a proclivity of Python. And the reason that's important is because we're going to configure Python in our next exercise. Further reading, there's a whole. These links are outdated, actually. You can take off the 5.10 and go straight to the most recent version of those docs at the top. But those are the docs for Bazel mod and Skylark globals. And for version override, there's the rules Python documentation if you want to go there and see exactly how you do all that stuff. And then there's the Bazel mod blog series. Again, Mike Bland has a whole host of blogs about Bazel mod. You can go there if you want to really deeply understand Bazel mod, and he walks you through like a sample migration from workspace to Bazel mod. Okay, so let's talk about the lab a little bit. The lab environment runs on GitHub, no need to clone. So I'll take you to the URL in just a second. You can go there on your laptops and follow along. There is a script to advance exercises. You just do /run underscore or no, next underscore exercise.sh. It is destructive though. It will do a git clean FD, and it will also do a git reset hard. So it will totally blow away any changes you have if you have not committed them to your your local version. So be aware of that. This is the wrong link. If you just go to EngFlow Academy, I'll show you in a second. It's called a Bazel Management Demo is the name of the repository. It is open right now as well, so you can just go to it and see it. Now, the way that you actually get into the lab is you need to create a workspace on main. So you see in the corner here, I'm going to escape the microphone, sorry. So in the corner, you see the code link. You click on it, you click on the code space tab, and then make sure you create a code space on main. Don't switch branches. You want to create it off of main. The way that the sort of looks when you get into it is you'll be in VS Code. And the README will be the instructions for your particular lab. There is a quirk in code spaces where the README sometimes won't refresh based on stuff that happens. So when you run the script, you might see the preview revert back to a previous version. So if you want to fix that, you click the 3 dots in the corner, and then there's a refresh preview. And so you do that, and then you should be able to get to the most recent preview. There's also, if you want to switch around between branches, if you click on the bottom left, it lets you. It opens a little menu at the top middle that shows you all the branches that are available, so you can switch to a branch directly if you want to. Okay. So this lab, I'm going to give you a little more time. I'm going to give you 15 minutes for this at least. I have a couple of helpers, I think, that should be able to help you. So raise your hand if you need help. What we're going to do is we're going to add Proto, Python, and gRPC extensions to the repository. They're going to patch gRPC to allow a gRPC library to compile. There's already a patch file provided, so you don't have to do anything special there. And then we're going to configure the Python extension. So by the end of this, like we have a repository that has some C++ and some Python. You should be able to compile all the Python and the C++ by just doing Bazel build // . Any questions there? No? Cool.
Can you show again how to start the development from it?
Yeah, actually, maybe the better thing to do is to. Oh.
Sorry, it's what was the length of the repository again?
The org is EngFlow-Academy.
Yeah.
Yeah. And then the repository name is Bazel Management.
New window. Yeah. I'm going to switch display settings just briefly. I'm going to mirror displays. so you can see what I see. You should see.
Yeah, you can.
Yeah. Okay. Cool. All right. So yeah, I'm gonna. What is it? There we go. So yeah, it's EngFlow Academy is the organization. You click on Bazel Management Demo, and that's the repository you need to be in. Make sure you're on the main branch. Click on Code. Make sure the Code Spaces tab is highlighted, and there should be a big green button that says Create Code Space on Main. And then I'm going to delete this code space and open a new one. Yeah, so you can see that process.
Anybody else getting network errors?
I am not. Yeah.
I mean, I'm having like slowness, which
Who's with the code switch?
Yeah, I don't know. Well, actually, like the I didn't mean to do that. There's no way no, just like the preview wasn't.
Oh, it is a little slow.
Yeah, it just goes like it. I went to a different tab and I came back and it's like,
The
oh,
preview
it's
takes a while. Yeah.
Yeah,
Usually
that's-
it's trying to open the raw file.
That's what I'm doing. I'm just gonna read the raw
It's a
file.
weird quirky thing.
Yeah, no.
Yeah. Code Spaces isn't a perfect solution, but it allows me to have a little control of the system itself, and then also makes it so if you don't have Basilisk installed or other things installed, you don't have to. So it's not perfect, but it's a nice compromise for really persnickety security organizations at telecoms and banks and things like that. So did everyone get to the code space okay? Yeah. Okay, cool. Wow. Okay, there we go. Okay. This is running on the free tier, so it's 4 cores. So it's not like a blazing fast container, but it is there is a disk cache on this, so you shouldn't have to build too much. If you know a whole bunch about Bazel already, this course might be a little redundant, but I would like think of this as a way to teach your up and coming Bazel productivity engineers how to learn Bazel. Okay, so when you do next exercise, you should see exercise 1, 2, add Python and Proto support. There's C++, there's Python code. It's in pretty straightforward places. There's a module.bazel file. So all this is having you do, there's a nice mermaid graph here to show you the dependency tree. Mostly this is just to have the versions. So you want to use these versions of the dependencies. So I think gRPC and Abseil aren't there. Protobuf isn't there. And Python isn't there. So you'll have to add those. Cool. Have at it for like 10 minutes, I guess, and raise your hand if you have questions, and we'll come around and help.
Latest versions of each module probably gonna work.
I don't know. Your disk cache won't work if you use the latest version, and so that means that you'll be sitting there longer than the rest of us.
The one who's on PCR.
Huh?
The most recent one, PCR.
Yeah, so that's not on the disk cache, so you're going to be sitting there longer than the rest of us. The versions that are in the mermaid graph are probably the ones you want to stick with just for now. That's so weird that it's so slow.
probably it's getting overloaded.
Hmm. I will say this. I have it open for now. I will leave it up through BazelCon. So if you want to attack these later at your Wi-Fi tonight in your room, maybe you'll have better results. So yeah, I'll leave it up for a little while so you can use the code space there. You can pull it down if you want to as well. If Some of the later exercises will fail if you're on a Mac, but that's the Bazel experience. Yeah, yeah, but yeah. But this part at least should work fine. I actually developed this on my M2 Mac, and it worked fine from this exercise up till at least the toolchain one. But then yeah, you don't have the disk cache either. How are we doing, everyone? Is everyone kind of done? No? One thing I realized as I was going through the slides and looking at the actual answer, if you got all the way through adding stuff to your build files, you may have to run. So you add that requirements target in your root Bazel build file. You have to Bazel run // requirements.update. It's only in the documentation if you look there. Like in the instructions, it tells you to do that, but I didn't put it in the slides, and so that's one thing I missed. But you might have to do that before you Bazel build everything to make sure that it actually does find the lock file and use it properly. I guess show of hands. Does anyone still need more time? A couple more people. Okay.
I think the requirements have as well underscore test, and you can see if your log file is out of sync of your bin file.
Mm-hmm. Yeah, there's a couple of hidden features of that target. That's which I think it. I don't know. I have mixed emotions about this because having the target dot function after that feels like not as declarative as I want my Bazel to be. Did everyone get their stuff to build? I guess the people who did finish. Did anyone get their stuff to build?
Who's got past the patch?
The patch.
Without looking at it.
Well, the good thing here is if you want to come back to this exercise, when you switch to exercises, all of this will be done for you, so you don't have to. You're not going to be stuck if you don't finish this in time. All right, last call. Is anyone having fun yet? Cool. I'm going to call time on this one. It's the least fun of all of the examples. And so the fun gets even more interesting later on. But I would say, like I said, I'll leave this up for a couple of days. If you need to reach me, I am in Bazel Slack, Billy Autrey, or you can email me, billy@engflow.com. So if you have questions or you need more access or you just want to chat or whatever, I'll be at BazelCon the whole time. So if you wanna explore this a little more, then feel free to hit me up. But like I said, when you do next exercise, it'll bring you to the whole thing. Or it'll bring you past this exercise to the next one. So it'll be a clean slate for you. So the gist of what we had to do here is in the module file, I added these dependencies. I added proto, gRPC, and abseil, the specific versions that were in the mermaid graph. I added a single version override. So you had to add this patch, right? But the problem was that the Bazel will very happily tell you, hey, I can't go to that build file because I don't know anything about it because it's not actually a package. And all you really had to do to get past that error is just touch build/build.bazel. And it would you have to stick a build file in that build folder, and that right like this. It doesn't have to have anything in it, but Bazel needs it there to make sure that it's a package. And once it's there, it'll actually be able to read that label and use it to patch gRPC. From there's so I pulled in rules Python separately. Like I said, I could put this anywhere in the file, but I just for clarity I put it here. I just pulled this straight out of the slides. You did use extension. I told it to use pip 3.11. And then I told it that there's a lock file here, requirements lock.txt. That file doesn't exist. And so if you tell it that a label exists and it doesn't, Bazel will again whine at you. So you had to touch that file too to make sure that Bazel actually does something. And then from there, the last thing I had to do was in this build file, you had to create this requirements target to tell it to take the requirements in and generate requirements lock.txt. And then that allows you to do two things. It allows you to do Bazel run requirements update, which will actually put stuff in your requirements lock file for Python. And then the other thing it'll allow you to do is do a Bazel build of everything. So any questions on that as whirlwind tour? Hopefully not too many gotchas there, but the errors at least are hopefully friendly in Bazel so that you didn't trip over anything too big.
Is that update just kind of magical?
It's a specific function for that target. Yeah, that's what I was just talking to him about earlier. Is it feels weird to me in Bazel that this is a thing for this particular Python target and rule, but like that rule has a couple of functions that you can call on top of it once you declare the target.
Is it actually a rule or is it not?
I don't know. I'm not a Python person. I just use.
I think it's a macro which creates several targets.
Oh, okay. So those are the hidden targets.
Yeah.
Those are the
You
hidden.
just do the query on the
Okay.
thing and you've got all the targets.
Okay. Well, that'll bring us very nicely, or a segue into my hot takes on macros. So remember this for later. Cool. There we are. Okay, cool. Let's go on to the next piece. There are other helpful resources here. I mostly want to at least get you familiar with the exercise flow and to move and touch things, but at the same time, I also want to get to the really cool part, which is debugging build at the end. So, okay, let's do macro hot takes. So before we get into that though, some of you in here may not know what a macro is, or let's just pretend that we're new Bazel engineers and we're learning for the first time. So you might ask yourself, what is a macro? Macro is really just Starlark that you can write as a function or a wrapper or extra code to instantiate other rules. It's like a very basic okay, let's say I want to I have this particular dependency. I'm creating a web dependency with some framework of some kind. And I always have to pull in these 4 dependencies every time that I instantiate it. It can feel kind of repetitive to do that over and over again. And so an interesting way that you might reuse that code is to write a macro that wraps that rule and then includes those 4 dependencies. So then instead of declaring, CC binary and always pulling in abseil, you might say abseil binary, and then it pulls in abseil for you as a dependency and adds it on to whatever dependencies you have for that particular rule that you're calling. So it's good for encapsulation, good for code reuse, good for validation. It's also pretty good for chaining rules if you want to, if you have, another example here is, let's say you're declaring a Docker container for a particular type of code, and you always have to, let's say it's a Java jar, because I'm a Scala person, like I said, I always think that way. So let's say that you're adding a tar layer that is a jar for your code that actually runs, and then you have to add that layer on top of the base image that you're declaring, right? So, and maybe a common use case for a macro here is to just pass it the Java binary or the Scala binary of the jar that you want to be your runtime, and then the macro can create the layer for you and then also add it onto the base image. So you're creating one image with one macro instead of having the developers create 4 or 5 targets for that image creation. So those are pretty common use cases. There's two kinds of macro syntaxes out there right now. There's legacy macros, where you'll see the documentation. If you look up legacy macros, you'll see what we're going to cover here in a second. And then there's also symbolic macros, right? So the idea is with legacy macros, it's been around for a very long time. It is just very much a wrapper. It's compatible with all Bazel versions. So if you're on 5, 6, 7, then you can use legacy macros all day, no problem. It doesn't have as much visibility control though. So there's some default sanity in the symbolic rules that is not there for legacy macros. So you have to be very intentional about privatizing things in legacy macros. There's no type safety in the attributes. So if you want to have specific types for the attributes in your macro, you're kind of out of luck there. And then it also has very basic function syntax. So it's actually really easy to use. You just declare a function, and then you take parameters and you call a rule under it, and there you go. You got a macro. Symbolic macros are a new API that came with Bazel 8. That gives you much more fine-grained visibility control. By default, any targets you create under it are private unless you pass visibility directly to them. There's type safety in the attributes. You can have some nice inheritance of attributes and like inclusions and default values and things like that. If you have ever written a rule, or if you looked at rule code, the syntax for symbolic macros actually looks a lot like a rule. So much so that some people at my company say, why don't you just write a rule? And then the last thing is you may not call glob. So hot take number one, which one should you choose? There's not really a deprecation strategy in symbolic macros yet, or for legacy macros yet. So symbolic macros are just like a nice to have right now. And also one of the main draws of symbolic macros is not actually true yet. You can't lazily load macros. It's a promise that's coming with I'm sure they'll announce it in a couple of days, and all of my slides will be out of date, but for now you don't get much benefit out of symbolic macros until they implement that piece. And so until you have a reason to use symbolic macros, or you just like really love type safety in your code, then, which I'm a Scala person, I do, but if you really want one of those features, then you can reach for symbolic. But our recommendation is, in general, just use legacy for now until you have a good reason to, because it's not that hard to shift once you've done it. And then also be aware of some restrictions, like you can't call glob. Symbolic also like really hates if you don't start internal rules or targets with underscore that are private. And that can also bite you if you depend on other dependencies like gRPC, and it has a macro that doesn't follow these rules. And so you had to end up patching it. Ask me how I know. So, so the restrictions can bite you a little bit with symbolic macros for now. So I already told you. Well, again, this code is from Google, so if you don't like it, blame Google. But this is straight out of the docs. This is an example of a legacy macro. Like I had said before, you just call def, whatever the name of your macro is. You pass it some attributes, just like a standard, function. And then it will do that, right? So in this case, what we're doing is this. Their example is you're miniaturizing an image. So you give it the name of the image, the source, the source attribute, has a default size of 100, and then you pass in quargs, and then it just calls general to call the convert function on that to resize that image. And so this is like a portable way to generate files that are smaller using general and a macro, so that you can just call it directly and create images. So some hints on legacy macros. Name is required, and quargs is, if you don't know already, a Python pattern. This allows you to sort of pass the rest of your parameters to the rule implementation as like a dictionary. So it's a dictionary of you can call miniature with a bunch of attributes, and all those attributes that are not declared here, at the top, all these attributes that aren't named source or size, like if you're adding tags or something like that, those will get passed down. Actually, I think this slide illustrates that. So in this case, I'm calling miniature, the macro. I'm naming it, hero mobile, and it's got some file as the input file. Visibility is passed in, so I don't have a visibility attribute on my macro, but it gets passed in through quargs. And then there's a data attribute, which, again, I don't have that declared automatically, but it gets passed down to the general. There's another thing you can do, which is, again, probably relevant to the exercise we're about to do. If you want to do a little bit of validation in a macro, you can fail. This is a load time failure, so you can't write a test for this, right? Because you can't write tests in Starlark for load time stuff. But if you wanted to validate in a macro, then and fail because you are very strict and you want to enforce something, then you can call fail directly in your macro and it'll fail at load time. So you can give nice error messages to say, hey, you're not supposed to do that. Yeah, so symbolic macro definitions, the way that you do those, I'm not going to go over the syntax of that. I do in the bigger course, but I'm not going to do it here. But if you want to, you can look it up. It's you basically call macro, you declare a rule, you call the rule macro, and you pass it like the attribute definitions that you want, and then you also have to pass it an implementation function, much like a rule. And so the implementation function should be private to whatever the BZL file is that you're using, and then that allows you to kind of create your macro this way, which again leans so heavily towards rules. One asks, why don't you just use a rule? Okay, best practices. This is on my last set of hot takes for macros. Overuse can create build graph confusion. So I guess what I would say here is that Bazel is, our inclination as programmers is to try and be as dry as possible, right? We want to reduce boilerplate code. We want to reduce the amount of friction. We want to reduce the amount of typing that somebody has to do, right? And so the tool that I see across my engagements the most that people reach for to do this in Bazel is to make a macro for everything. They just want their API to be like, okay, a developer just has to type macro this, create the name, point it to the source files, and then it does all the magic for them, right? The problem that I often see is down the road, right? You might have like 6 targets that get created under a macro. And you can imagine, let's say I have 6 different, like JavaScript is a great example. Let's say I'm declaring a JavaScript target, I'm declaring a TypeScript target, I'm declaring Webpack, I'm declaring ESLint, I'm declaring Jest, I'm declaring like all these targets, and they all get declared by one macro. So I just call one macro to create all these synthetic targets. Well, problem number 1 is the targets don't exist anywhere. So if you try to use Bulldozer with the errors that get produced out of that, those commands will typically fail, or you'll just confuse your developers because they're like, I don't know what this target is. You have to be very specific about the name of your targets to make it sort of make sense. And then the other problem you have is this JavaScript example I have. Let's say that I want to include, I want to add an attribute to only inject some sources into Jest, or I only want to inject a particular source file into Webpack or whatever. If I have attributes that I only want to send to one of those 6 underlying targets, you can imagine what would happen to the signature for my macro. It'll explode because I have so many targets that I'm having to individualize access to. And so I guess what I would say is, in general, the best practice is to limit macros to only produce one public target. All the other things that you create under that macro should be like helper, and they should be named _name _ whatever it is, so that somebody at least has a hint that this is a private synthetic macro and it's pointing to this thing that's named something that I know about. So I guess I don't know, maybe it's not that controversial, but I find that I push back the most on these sorts of things in PRs when I see them. And then the other thing that I would say is, in general, resist the urge to wrap everything in macros. I would start to think about Bazel as like explicit configuration over convention. Which is kind of the opposite of what you might want. It's almost like infrastructure code or as build or whatever. And so you can like it feels a little gross at first, but it gives you more visibility into what's actually happening at the build level. And I know that it can create friction, but with tools like Bazel, with good training, with judicious use of macros, I think you can create a good API without leaning too far into the dry space, into trying to create conventions that end up hurting you in the end. So those are my hot takes from experience. Any questions? Any tomatoes? No. Okay. Cool. Well, let's write a macro. This should be a lot easier than the other one. So I'm gonna go to the next exercise, and this is gonna take me to the macro exercise. There we go. So what I've done is I'm enforcing, and maybe this is not a hot take, but this is a thing that people do that Bazel warns against, but only in like a note somewhere buried in the documentation. What Bazel tells you is, if you're using protobuf and you're using a proto rule or proto library, your proto library should only have one proto file associated with it. And the reason for that is that if you have a proto library and it declares like 6 proto files under it, that means that you have a whole host of applications that depend on that generated code. And so if you touch any one of those 6 files, everything that depends on any one of those proto files has to be rebuilt, all of it, and regenerated. And so the proto file is so low level that the ramifications of grouping those source files can blow up your entire build graph. And so buried in a footnote somewhere, Bazel tells you you should only have one proto file per proto library. So what this macro is doing that we're going to try to enforce is we're actually going to try to force people to do that. There's some in exercises 2.1 and 2.2, I have students create some Starlark to actually check the input list to see how many protofiles are there and to bomb if it doesn't follow those rules. And so in this, what we're doing is we're wrapping proto library, creating a macro called validated proto library. It calls a validator function and fails if it detects more than one proto file. Yeah. I'll give you 10 minutes for this one, now, since y'all are in the code spaces now. Hopefully it doesn't take that long to type in your IDE. And raise your hand if you have questions. How are we doing? Good? Was this one easier? Cool. All right, I'll go over it real quick and then I'll let y'all go do human things for a little while and then come back and be bored by me. So the macros of EZL, all I did was, so I had to import validators and I had to import the proto library definition. Declare your function here. And then what we're doing is this validated proto sources is a function that, again, you create if you take the full course. And we're just calling the function. And if it's false, then just fail, with some error. Anyway. And then once you get past this, that means, we're assuming we're true. So then go ahead and create the proto library. So we do that. And then the other thing we do is in validated proto library, I call, I import it first and then I call it instead of proto library. And then that tells me flight tracker proto is being pulled incorrectly. So if we wanted to test this and see if it worked, we could do comma and then do user.proto. And I believe it will fail now.
It's users.
Users. So it did fail, but for the wrong reason. Error validating sources right there. So yeah. Cool. If you wanted to improve this, in fact, I probably will do this later. You could have the actual validation, give you a little error about what was actually wrong, and then return it in a tuple, and then read the error from the validator function. You could do all kinds of sophisticated stuff with this. You can write real code, not just contrived code that I come up with in vibe coding. But yeah. So anyway, but this is just a very simple example. I would say don't go crazy with macros, but in general, you can do all sorts of useful things, having different libraries, imposing some validations, doing some smart errors, things like that. There's all sorts of fun you can do with this. And with Starlark and unit testing, you can, it's a full language. The sky's the limit on what you can do with this. You could write Snake with Starlark if you wanted to. So, okay, cool. That's it for this one. I will we'll come back at 2 and we'll start the next section, which is default rules and configurations. We're getting building up to A-query and C-query. Cool. See you in 10. Or, you can stay here, whatever you need to do. All right, let's talk about default rules. There's a bunch of them. You have the slides, so I'm not going to go over every single one of these. Probably I'll point out some of the most interesting ones, though. Well, actually, we're going to go into some of these in more depth in a section. I'll talk more about file group and jQuery in general. But this is just a nice reference slide to show you some of the kinds of rules that we're talking about here. And I think the more interesting included rules that you'll probably end up using day to day would be general. General is overused, in fact. And then file groups, of course, are pretty interesting. And config settings are useful for particular types of problems. Not everyone would use them, but I think they're going to be useful for us here in a little bit. Let's talk about some of them in depth. First is general. General is, if you don't know general, it's a simple simple single task, right? Like if you want to do a very simple thing, a very small compilation, a very small file generation, you want to manipulate files, encrypt files, things like that, then general is pretty useful. It's great for when no rule exists for the task and you just want to kind of quickly cobble something together. It does not have dependencies, so you can't add depth attributes to it. It is not intended for tests, so don't use it. Don't use it to run a test. So don't I would say, like, if, for example, don't write a jest test and then use general to call jest. Like, that's bad. Don't do that. And what it fundamentally does is it runs a command in bash, like it wraps this command that you provide in a bash script, and it does set EO pipe fail. So if your command fails for whatever reason, then general will fail. Like I said, the use cases. So if you want to compress files, copy files, manipulate files, transform them very basically, if you want to execute a package task, or if you want to do some very simple file manipulation, like moving things around or copying them or sort of transferring them around for the work for the exec root, then that can be pretty useful. It's generally like if you want. It's file transformation is how you can think of general. It's like general purpose Swiss Army knife file manipulation. General recommendations. So this is going to look pretty familiar after a while. Don't rely on the local path because this harms hermeticity, right? An example of this, somebody was telling me that they had sed in something, right? If you have sed, for instance, in a general, that's like an interesting thing where you might, run regex on some code to do some stuff. Well, if you're depending on sed in the path on your whatever box it is you're on, if you run it on a Mac, or you run it on Linux, you're going to get different results, or they might have different flags. And so if you rely on the path, it's going to break hermeticity, it breaks expectations, and it can force rebuilds if there's issues in the path. The other thing with general is that if you use general, you have to be really careful about determinism. It's very easy to write a general that includes a timestamp or includes, ephemeral data, like randomized data, or that doesn't sort data and ends up producing different results as a result of it. So, like, as much as possible, if you're using general, really, really pay attention to your determinism for the inputs and outputs. There's also a handy tool, $location, if you want to look up the location of a label. So if you want like the relative path of a particular label when doing stuff with general, then this will help you. Okay, so I'm going to harp on determinism a lot in the next couple of hours. This is an example. So let's say I have a stable input.txt, right? This is just some input file. It never changes. Let's say I have a gen rule and its name is randomize and it does what it says. It randomizes the inputs, right? That means that every time this gen rule runs, the output is going to be different. So what happens if I have a PyTest that depends on this randomize file that gets generated by general?
Always test.
Huh?
You can always test.
It will it though?
That's when stable input changes.
Not always. It depends on hash that's going to be returned. If it returns another hash, then you essentially have to rerun the test because the hash is not.
Yeah. The answer is quite nuanced, but yes, that's the short of it. Is like if anybody runs it, it will generate a new hash. And that means that the inputs for PyTest will be different and it will cause PyTest to rerun. But that answer changes if you have a remote cache, or if you have a disk cache, or if you are running it on two different systems. So the randomness is not as clean cut as it will always rerun, unfortunately. That would make it super easy to find in my job. But so this is keep this example in mind because we're going to come back to it after a while. Okay, so what does it look like to actually declare a general? It looks like this. You give it a name, of course, because you give everything a name in Bazel. You give it your sources. you give it outs, and then you give it the command. The command is the thing that gets wrapped into a shell script. So in this case, what we've got is two sources. One of them is a file group with multiple files. So you can pass in multiple files if you want, or you can use other gen here, like some other file, right? So you can include any group or any grouping of files that you want as sources into general. If you're doing a file group or a list of files, then you can use locations to access those. If you're just doing one file, you can do location of that particular source. If you're trying to glob them all together, there's another shortcut here. You can do like $sources in all caps, and that will include all the sources from your inputs, kind of like make. So anyway, that stuff is sort of inherited there. And then outs here, the idea is that you're generating, in this case, again, blame Google for this code, but in this code, what we're doing is taking a whole list of files and concatenating them all into one source file that's called concatenated.txt. And so this is how it does it. It just does a cat of locations of this file group and location of this file, and then pipes it all out to $@, which is a shorthand for the output file. Yeah, so that's a whirlwind tour of gen rule, foot guns included. Any questions? No? Cool. All right, SH binary and SH test. SH binary and SH tests allow you to incorporate shell scripts into your build. So if you want to do like a common example that I've seen and recommended before sometimes is like if somebody has containers or things that they want to do that depend on scripting to kind of do, and you want to do it on remote execution, then the easy way to kind of do that is to like you wrap the stuff that you want to do in a shell test, and you remotely execute that, and then it will execute all of that stuff on your remote executor, right? But in general, like if you have shell scripts that do anything of any sort of import or use, that wrap tests, that's simplified logic, that do generations, things like that, then shell binary is a really useful way to get some remote caching and some hermeticity into your environment. Shell rule considerations. Again, this should look pretty familiar. Don't rely on the local path. And the other thing you don't want to rely on is your local env, because your env can change subtly, and that will leak into your build, and then you'll have a hermeticity issue, right? Suddenly you're pulling in something from the env that you're not expecting, and the hash key changes. Again, with shell rules, it's really easy to randomize things or accidentally, hurt determinism. So shell rule is the same as gen rule. Very easy to do this. It's the most common thing I see, I think, other than generated code with timestamps creating hermeticity issues. And then also there's this is a little bit broken right now. I think that Fabian is working on this right now, but our location is a library suite that you can use for different languages to get the location of a label in the runtime location or run file location in the workspace. And so our location is available for shell script, it's available for Python, it's available for a host of languages, but you can import it in your shell rules, and that will allow you to get in the shell script the location of any particular label, so you can feed that into your shell script if you want. That allows you to enforce hermeticity. Shell test is pretty straightforward. It looks like any other rule. You've got your name, sources, data. Notably, you can have dependencies for other shell scripts if you want. But then if you want to, let's say I want to run, in our example, what we're going to do is we have C++ code that runs as a binary, and then we have a Python script that runs as a client, right? And so in order for us to have access to that binary, you need to input it as a data source, because it's a run file for that script when you're running it. It's not a shell script, so it's not a source file or a dependency. So if you're doing shell tests, then you want to, and you're doing it to stitch together tests for other languages, you want to include those other binaries or other tests as data. And that takes us to the next lab. This one's pretty straightforward. I already described to you what we're going to do. You're going to create a shell test to stitch together Python and C++ code. You don't have to write the shell script, so don't worry about that. Don't panic. We're just writing the Bazel to tie it all together. while I'm doing this, any questions on those few things so far? No? All right, refreshing my preview. So we're going to create an SH test. So if you look at the SH folder, you should see a new build file, and there's a new shell script. And then what you're going to do is use general to replace the hard-coded flight data.json. That's going to end up in a run file, and then you're also going to create a shell script to run both of those pieces. As always, raise your hand if you have questions. And yeah, I'll check back in 10 minutes, see how you're doing.
A similar scenario, but we want to access another shell script to the same directory.
Mm-hmm.
It's the same flow.
If you are accessing another shell script from the same directory, I would include it as a dependency. Yeah.
But it is not available in the
It's not available what?
It's not only that it is copying the shell, what are the shell script, but what are the additional shell script that we mentioned in the dependencies not available in here. But the same classic.
Yeah. Well, I think you can include it as a dependency, and it probably is available. The location just may not be what you expect. You can, if you want to, you can actually look at the run files and the output base to kind of see where the shell script is. So actually, in the full course, I show you exactly how to do this, and we'll probably touch on it a little bit. And in this exercise, I'll show you. But yeah, it's probably all there, not just maybe in the way that you realize. Mhm. Let's go ahead and look at the exercise together a little bit. So the idea here is that in Python, in the Python folder, there's a flight data.json. And now what I want to be able to do is use this flight data extended JSON instead. I want to test it with this larger file, right? So the first thing we're doing is dirty hack, which is just to copy over the flight data extended into the flight data location. Essentially, the Python script is written by a bad person named ChatGPT. And they hard coded the location of their JSON file, and so we're just a lazy programmer, and I knew that I could write a gen rule to hot swap the file out from under. It doesn't actually swap it out in your workspace if you're not familiar with Bazel and how it works under the hood. It just replaces it in the sandbox, so we're not in any danger of losing any data or anything like that. But like I said, it's a dirty hack. Don't do this at home, please, kids. The other thing that we're doing is we've got this shell script, and it's going to call the C++ server first, and it's going to wait around, and then it's going to call the Python client once it thinks the server is up, and then it will exit everything cleanly if it all passed. So pretty straightforward. What I have done is first I have this gen rule to copy the file, and then instead of passing in flight data.json into my PyBinary call for the test, I'm just calling the general target that I've created. The other thing we're doing is in shell script I created an sh test. It's using the shell script, and it needs two dependencies for data. Like one is the flight server, the C++ code flight server binary, and the other is this backend functional test Python binary. So it needs both of those as Python or as data dependencies, so it can invoke those in the shell script. Once you do all that, it sort of works. So follow-up questions. I gave this one away already, but is the use of general in this example a good practice?
I am actually surprised that Bazel didn't complain there was a file there, because it seems like the label for that file would suddenly be very.
Oh, what do you mean?
Because I thought, maybe I'm wrong, and maybe it's been a while since I did it. I thought sometimes with generals you could still refer to the generated file as the label, as the name, like the colon data.json. And the fact that Bazel would have a local version and in the build tree see no, but it's generated by this general. I thought Bazel would be like, no, you can't do that. For some,
It-
I thought I've hit that before. But
It will do that if you have it as a data dependency and you general try to do things with it.
that's what, yeah.
Yeah, so the reason this works here is because in the sandbox for this particular
Yeah.
contrived scenario, I'm only depending on the general, and the general takes the
Yeah.
input, and it pretends that the flight data extended doesn't actually exist in the sandbox, and we'll just copy it over, right? So like. Oh, actually, no, the opposite. It takes the flight data extended as input. It pretends flight data.json doesn't
It
exist.
doesn't need to know it in this particular. It makes me think that if you use that as well,
Yeah.
this it would. Like if you had a build that tried to do all of it in the sandbox at once, it would have.
Yeah, exactly.
Yeah, it's weird. It's very. I don't like it.
It is very weird. Yes. It is. Yes. Cool. Any questions about this? Did everyone mostly get it working? I think a couple of you might have still been working. Cool. Okay. Well, hopefully at least it gives you an idea, like hands-on creating general, how you can refer to gen rules as like data files, and then how you can stitch together tests with shell test. So.
Do you have any suggestions about in the shell test itself? You have a path to test the data dependency. Do you have a suggestion about how to wire that up a little bit better, or
How to not vibe code it? Yeah.
well, I mean, more like variable substitution. It's like how do you get the rather than just like the path you expect it to be? Or maybe that's good enough, right? What is your suggestion?
Earlier, I mentioned in shell test that there's an R location, so the runtimes library. There's a runtime library for Python as well, and so what I would do is probably substitute in the runtime and then put in the actual label of the thing that I was trying to put in, or maybe even feed it in as a shell command, something like that. So you've got a couple of options there about how to do that, but there's ways to use the Bazel API itself to get at the runtime location. Cool. I will do this really quick. If you kind of want to see what it actually did, this horrible hack, you can get to it through. So if you go to Bazel bin, this is your bin output. You can see the run files through here. So I'm going to look at the shell one. If you go to shell Python, you can see flight data.json, and this is the extended one. It has like a bunch of strung together flight data. And if you compare it to this flight data.json, this only has 3 entries. So you can see that in the workspace, it is flight data extended JSON, but in the shell test where the run files for the Python stuff get actually, copied around and used, and the general gets executed, it did copy the other file over it. But it's only in this, it only exists in this hybrid weird state here in the workspace. So yes, now I've taught you all how to hack the workspace. Thank you for doing that and making my job harder. Okay, cool. So let's keep going. Let's talk about other things. File group. File group is if you have code or files or inputs or things like that that you want to reference as a group, but you don't actually want to do anything with them, right? Like you just want to make Bazel aware that these files are here, they're a thing, just know that they're there so that I can reference them later. Then file group is your tool for that. It's also really useful if you have, let's say for instance, I have this flight data.json in my Python test folder. Let's say that I actually want to refer to it directly in the shell script somewhere. Well, the JSON file is not an input file or a source file for a rule. It's just a file. And so the only way to expose it so that I can access that file outside of the package that it's in is to wrap it in a file group and then change the visibility on it. All right. So so if you want to mess around with visibility, expose things around the workspace, things like that, you can use file group to do that. One small quirk for you in the documentation, it says that if you add a directory as the file group source list, or in the file group source list, it will happily let you do that. But if the contents of the directory change, Bazel isn't aware of it. So if you want Bazel to know that the directory and all of its contents are relevant to this particular file group, you need to glob the file because then that will force Bazel to look at all the files that are in the directory that you add and calculate hashes for all of them together as that one target. And if one of those files changes, then it can change the file group. So just be aware of that. If you add the directory, you might get weird problems.
So is there any way to, let's say I specify my tips as 200 files, but in reality when Bazel is running maybe only 2 files, is there a way to get access data to say these are the real dependencies, like your rule is like if you have specified
I mean, you can have any number of files, individual files or globs of whatever you want.
what I meant is any way to ask Bazel to emit all unused dependencies.
I don't think you can do that for file group. I don't know that there's a way for Bazel to know if you're using or not using the file. Unused dependencies are a thing that some rule sets let you do. So like I know that Rule Scala, for instance, has like a unused dependency flag that you can set at the toolchain level. I believe C++ has something similar. But file group is so generic, there's no way to know if a file's used or not in the glob. So you'd have to. I mean, the trial and error way to do that is just to only individually add the specific files you suspect are not being used or are being used. And then the new hotness way to do that is to throw AI at the problem and let it figure out which files are being used and not used. And trial and error it, with the computer. But yeah, the file group doesn't have any sort of flag or anything like that to do it.
If I have some file outside my workspace in NFS mode, so does the file group over here, which is outside my workspace?
So you're saying you have a file that's in an NFS mount somewhere, and you want to use file group to access that? Not out of the box. You would have to tell Bazel to look at that external directory as a repository. So you would use like a local directory override or something like that, and then it could access it as a repository. And then you could then, when you declare dependencies like that, you can, if it doesn't have a Bazel file in it, like a workspace file or something like that, you can superimpose one over it. Say, hey, this file that's over here, you pretend that this is the workspace file for this repo that I set up, and then that will tell Bazel how to interpret file groups and things for that particular piece. In fact, in the module that we don't go over about the tool chains, if you inspect some of the code, it actually does that. You download Clang, and then in Clang you in that download that you pull from some RPM or something like that, it superimposes a workspace and some build files over it so that it can pretend that it's a Bazel workspace, and I can get to where the Clang file actually is.
That NFS location doesn't have any file, or it's not a Bazel repo, it's just a group of files. Yeah, like you said.
Yeah, you would have to superimpose it and treat it as that's how I would deal with NFS. I also, well, I have other thoughts about that, but I won't go there. Yeah, sure, no problem. Any other questions? Cool. So that's file group for you. That's what it looks like. There's no reason to go too in depth on this, but you can have targets or specific files, just names and sources, and then of course all the other, you can add tags and visibility and whatever, but it's very straightforward. Okay, here's where some of the fun begins. In I believe this is in Skylab actually, but there is a type_flag rule that is pretty useful to use. The idea here is if you want to create a custom flag that you can use at the command line for whatever reason you want, then you can use, type_flag. So what I mean by type, the reason it's in brackets is it's for specific types. So you can have an int flag or a bool flag or a string flag or a string list flag. So this lets you specify a bool at the command line to affect the behavior of Bazel. It supports finite and default values if you want. So yeah, just kind of an interesting little tool. The way that you use it is this. Like I said, it's in Skylib. So in this case, I'm importing string flag. You call string flag and you give it the name, so the name of your flag. you give it, you can build setting default is if you want to declare a default value. You don't have to set this. And then here you can define the finite values if you want it to be like only one of these three things, like an enum instead of just an open string. So in this case, I think again this is from the documentation, but in this case we're setting like a coffee or a tea temperature string flag, and so the default is warm, but you can set it to hot or iced. And then the way that you actually set it, like you say Bazel build the whole world, and you say dash dash, and then this is the package colon the name of that target. So this is a bool underscore flag target that we define called bool. So my custom bool, and then you set it to true, or my custom flavor string is apple in this case. So in this way that you can like pass values into custom string flags and things like that to affect the behavior.
I got a question. Is there a way to like define some kind of yes? Because like this kind of like my customers are probably going to say, oh, I don't want to use this because slash something.
You could create an alias.
Oh,
Huh?
like an actual alias.
Yeah, there's an alias. Yeah, it's I think the first slide, but there's an alias target that is a built-in rule, and you just give it like the name of one thing and then the name that you want to substitute. So put it in a favorable location and alias it, and there you go.
I mean, the RC, here's also in the RC file. It can be also set at the configure aliases for such settings.
Yeah.
Talk to us.
Yeah. The RC file, we don't go over RC files in this because I felt like it was maybe a little too basic for what we were doing here, but I do go over it in the extended course just because I want to cover everything. But yeah, RC files are another way you can set defaults if you want. Related to this is config setting. So this config setting represents a set of configuration values or constraints. So if I have a configuration value or a constraint and I want to sort of match against those for particular configurations, then config setting lets you do that. You can use config settings with select to match configurations and change build behavior. All the values in a config setting must match for the select to apply. So it's like it has to be an all or nothing thing. So as an example here, CPU is a built-in constraint. And so in this case, I'm setting CPU x86. And then also in this config setting, I'm passing in a string flag, right? So I've got my string flag, my custom bool. So in this case, what I'm saying is if the CPU constraint is set to x86 automatically or manually by the platform, and my custom bool flag that I created is set to true, then this x86 custom config setting is also true. But it's only true if both of these are true. So this is one way that you can kind of, if some of you have used selects before, this is probably like starting to get the wheels turning a little bit. And then selects, if you don't know what a select is, you can use it to substitute labels given a config setting or a constraint. The output is a list, so you can kind of think of it as like the select takes as input a dictionary of keys, constraints or config settings, and then the values are the list of labels. So that's what it looks like. You use selects most commonly for tool chains and source files, but you can use it kind of for anything. You can imagine like with custom flags, you could do all sorts of things with this. We're going to do some fun stuff with it here in a little bit. Okay, so as an example, let's say I have a CC library and I have this custom behavior that I want if I set my custom bool to true. Then in my select statement, what I can do is this x86 custom config setting that I set earlier. If that is true, so if the CPU is x86 and my custom bool is true, then I want to use custom CC as the input files for this CC library. Otherwise, in a default configuration, I might want to use default CC. So in this way, you can kind of manipulate there's other ways to do this for C++ and for tool chains, but this is one way that you can think of that you might want to affect inputs to sort of change the behavior of Bazel in different ways. There's far too many ways to do this in Bazel. There you go. There's arrows pointing to everything I just explained. Okay, cool. So let's do it. What we're going to do is there's, as it was pointed out, you could have some collisions with the different kinds of inputs. And so now what I've done is in the inputs for the the JSON files, I have a short and I have an extended. And what we're going to do is create a custom bool flag to say, if this flag is true, I want you to use the extended file. Otherwise, if it's false, I want you to default to using the short file. So the general is going to change a little bit, and then we're going to add our custom flags to kind of change the behavior. Oh, and then one last thing, the conditions default. This is a built-in target. So this is your fall through. So if you have a select statement and you want it to fall through to a particular behavior, conditions default is how you do that. You tell it this is the inputs for a default behavior. Cool. I'll just check in on you in 10 minutes and see how you're doing on this one. Again, as always, raise your hands. There's plenty of us here to help you out if you need help. So for everyone else, the question was, my place uses so many flags, they break everything, and it's causing flag hell. How bad is it going to be if we try to rip out all the flags? Something like that? Yeah. Well, I guess if everything builds without the flags set, like if you rip out all the flags in the CI, then theoretically, like you should be able to function fine. I would assume that those, well, if I were designing a sane system, those flags would only do like very, very specific behaviors. But if the system depended on those flags being set to certain things, then that's just all kinds of trouble.
Yes.
So I guess, I mean, like anything, you know, code is very versatile. It's there's no endless numbers of ways that you can harm yourself with it. So I guess I would say that this is not something that I would use all the time. There, like I said, there's lots of ways to deal with configurations in at the toolchain level, and so I would say don't use this all over the place. And it's probably a good idea to pull out the ones that are hurting people, the ones that don't have very specific purposes. If I was using a flag, I would make sure that there was a default, that it works with the default without any configuration set, and that setting it doesn't break anything else. I would maybe make that like a lint step or a config step or something like that. Like you can maybe query for things of that type and then test them all that way, you know? So anyway, that's just me thinking, not thinking about it too hard, but just outside the box, just, you know, kind of thinking about it briefly. Those are the things I would start to worry about and try to not control, but maybe put guardrails around. Is that? Yeah.
Lint is a good idea.
Yeah. Well, thanks. Okay. So I'm going to go ahead and go over this so we can get to the cool part, which is querying for these things. So the first thing I did was in the build file, the /build/build.bazel. I created the config setting called CI. Earlier, one of the comments made, if you didn't hear it, was that it's kind of annoying that you had to set this to a string, not the type true. But here you can use the type. So the type safety is weird here. So just be aware of that. It is kind of annoying. Anyway, so I created the bool flag. The bool flag has a build default and has a name extended test, and we're just checking this extended test to see if it's true or not, to see if this CI config setting is true. So if we set this flag, this config setting will be true, so it will trip it if we use it in a select statement. So the next thing you want to do is use it in a select statement. So in this build CI, what I'm doing is I'm saying if this CI flag is set to true, then I want to use this flight data extended.json. And if it's not, I want to fall back to this short. The idea being, like, you can imagine if I'm in a CI system, I might want to have an integration test or a unit test that's maybe a little more extensive or than what I'm doing, you know, in just a normal local test. I don't know if it's a good example or not, but it's just, you know, something to do. The other thing that I'm doing here is, I alluded to this earlier, but if you do sources in all caps, that will do all of the sources, so you don't have to have the specific location. Yeah. So this is we change the general, we change this flag, and then that allows us to do this. It's kind of hard to see here, but I'm just doing a Bazel test // sh wildcard, and then I'm passing build extended test equals true. And if I run both of these, they both run. So like I'm running extended test equals true. And what we can do to verify that it's doing what we want, it's, the general is actually copying or swapping out with the extended file. You can, again, look at the run files in the bin sh. You can see flight data.json is the extended. And then if I then do it with false, it'll run the test again, and the contents of this file will change. The contents of this file will change. Well, it worked on my computer.
I had issues with it. If you have, I don't know if you have to file it, but maybe caused it. I definitely had issues with like it not looking like it changed. Then I reopened like a cache.
Yeah. Yeah, I think it might be that it cached, and so it's not running the general again.
Yeah.
Yeah, I think that's my main problem. So, but yeah, it does actually work. So, just trust me, bro.
Small question, if you go back to the definition of flag.
Yeah.
Did you purposely use a tool label, like / build? Because I just used the whole extended test, and that still worked, but should I be using the full path?
No.
It's in the same package though.
Yeah, it should be fine.
Nothing to do with the visibilities later on.
Nah, you should be okay. So, I don't. Yeah, there's no reason it should have a problem with that. I don't know. I don't know why I did it that way, but habit maybe.
I'm just gonna say, just because we noted the string issue, I just was curious. It does verify that it's true or false, so it won't just let you put any string there.
No,
It
okay.
does have a little bit of safety. It just looks bad.
Oh, I have opinions. Cool. Any other questions on this? No. This things being cached and not being able to verify in the run files is going to come back to haunt us.
I guess the string 0 also works.
Because it's falsy, maybe. Because it's sort of like a sort of Python. Like if you squint at it, yeah. Okay, cool. Let's talk about queries and flags next. This is straight out of the glossary on the Bazel docs. So if you don't like it, go blame Google. The way that Bazel sort of works is there's a load phase, an analyze phase, and an execute phase. This is important here in a second because we're going to talk a little bit more about analysis. If you went to BazelCon a couple years ago, Benjamin gave a talk and he talked about this, and he said it's not as clean cut. It's not like Bazel does all the load and then all the analysis and then all the execute. It does this like ebb and flow of doing load and analyze and execute all as it goes through things and down the dependency chain and builds things. But in general, it's for our purposes here, you can kind of think of it as like, I'm first for any given thing, it's going to load the file, and then it's going to analyze that file and crawl through the chain and analyze those dependencies. And then after it figures out what the whole dependency tree looks like for that particular target, it can go ahead and execute the command because it knows enough to say, these are all the inputs, all their files are valid, they build a real tree, so I'm going to build that tree now. So this is important because of this scenario. So let's say we have this scenario where we are querying for the depths of an ash. This is a type of tree, right? So we're querying for depths of ash. The implied here is that we're only querying a depth of 1, and we're not getting inputs at depths. So let's say in my shell library, I'm depending on mana ash and common ash, which are both shell libraries that are defined over here on the right, right? So if I have a select on here and I'm selecting on the condition of Excelsior or falling through to default, and I query for the dependencies of this ash target, what am I going to get? Both. That's right. So if you do a regular query, Bazel doesn't know which one is the actual dependency. And so it gives you both as the answer, right? That's kind of weird. Like, why does it do that? Well, the answer is because query operates at the load phase. But what we really want to know sometimes is which file are you actually using Bazel? Like, what is it actually trying to do, right? This is where cQuery comes into play. cQuery operates post-analysis. So it will pass load phase and go all the way to analysis, which takes a little longer, but it gives you better results. And it also takes into effect all of the configurations, all the flags, all the stuff that can affect select statements. All those things are taken into effect when you do cQuery. And so if you need to know for a given configuration, what are the actual input files that are selected? What are the actual tool chains that are selected? What's actually going on under the hood, Bazel? Then cQuery is the tool that you kind of want to have configuration aware query of your build graph. So if we take this scenario that we had before, right? I do a cQuery for no implicit depths for this. What it's going to tell me is, okay, well, you don't have any, this Excelsior flag doesn't match, so I'm going to fall through to the default. So in the default situation, common hash is the dependency. The other thing you're going to notice is that there's a little hash there. Does anyone know what that is? That's the configuration. So if you want like a fire hose of like all of the stuff that Bazel calculates as that is part of that configuration, including like the flags that make this actually true, you can do, I believe it's Bazel config and pass it that hash and it will dump what that configuration is for you. So this is pretty useful. So like if you change your flags, then you can switch back and forth and see that the configuration is different for the different queries. Action graph query. Yeah, sure.
Do transitions generate configurations essentially?
The question was, do transitions create different configurations? And the answer is yes. A transition is basically just a function that automatically calculates configurations that then will be superimposed on your targets based on whatever logic you impose. So it's just, it's exactly its purpose is to.
Respect those. You mentioned Bazel context, like the down configuration values. Is there a way to respect those?
Yeah, so if you do cQuery, it will give you the configuration for a given set, and then you can then query Bazel config that hash, and it will dump exactly which. Yeah, so that the transitions are the exact scenario I think where people will find the most use in cQuery. So I don't cover them in the course actually because reasons. It's a kind of a complex topic, but yeah, you're exactly right. I do mention it a couple of times that they're pretty useful for transitions as well. Good question, thanks. So aQuery, aQuery is a little bit different. This gives you the full action level properties of the graph that you're looking at, and so. Most of the time, if you're thinking about Bazel at a very basic level, you might think, okay, I have a CC library. That just means it's going to run CC compile, and then it's going to produce this .o file at the end of the day, right? The reality is that to create that O file, Bazel might have to also link. So it has to do a C++ compile, C++ link. There are other libraries and rules and things where the targets underlying them are a series of multiple commands. And each of those commands that Bazel has to issue is an action. So an action is like a set of inputs, set of outputs, and the specific shell command that gets run to produce those outputs from the inputs. Now, aQuery is super useful because sometimes you want to know what is the actual action that produces my file, or what actions depend on this. Or a real world example that I got asked one time when we were doing a trial for a customer was we had recommended that they use a particular macro that expands into like Rule Scala is broken. I'll put it that way. Rule Scala is broken because discovery is broken in test discovery, and so you can't do sharding in Scala. Like you can't do set shard count at the test level. So there's a macro to just hack it by running, assuming every test is a single input, and it creates synthetic test libraries for every file that's globbed together, right? So it's kind of a hacky way around doing shard count for Scala test. So we recommended that they create a Scala library around their test to compile it first, and then do the test after. And they thought they might do a multiple compile if they did that. And we were able to show them with aQuery at the action level, it doesn't do that. Like there's not that many compile actions for those, and that they depend on the compile for the underlying library first, and then the test can just execute once, and the test compile can only execute once. So if you want to sort of prove what Bazel is actually doing at the action level to make sure you're not doing redundant things, that the things that it's actually considering the graph properly, then aQuery is a great way to do that. aQuery also does analysis, so if your analysis is really slow, then aQuery is going to have to do that. You want to do it on a warm Bazel.
I have a question.
Yeah, sure.
I've been told, but I have no proof myself, that sometimes you need to do build no build, dash no build, to like do a full resolution, and sometimes aQuery doesn't get that far. Have you heard of that?
I haven't heard that one. In theory, aQuery should do the analysis of the targets based on what you put in the scope, right? And so I don't know. I have to think about that. So I could see like as a hammer, like if you really wanted to make sure everything was in the Merkle tree and the analysis is done for the entire world, then yeah, that's one way to do it. But if aQuery does not do the analysis for everything that's under the scope for the action that you're concerned about, then I would say aQuery is broken and that needs to be fixed. Yeah.
This doesn't. I don't know if it's exactly answers the question, but someone familiar with implementation, aQuery and cQuery literally do build dash no build implementation.
Oh, okay.
It's always possible there's some parameter that does something weird, but I would be surprised.
Okay. So in that sense, yeah, I would say that I wouldn't do that. I did not know that I did that under the hood. But I mean, it does analysis, and so I mean that's a hammer way to do it. So yeah. Cool. So when to use aQuery? I mentioned earlier, actions are inputs, outputs, and the commands that run them. So if you want to inspect action relationships, like what actions come out of a particular target, or how do these actions, sort of relate? If you want to look up a mnemonic for a particular action, if you want to inspect the actual inputs and outputs to see exactly which actions use this input file or which actions generate this output file. And then also if you want to look at the action keys or look at the actual command that gets executed for an action, then aQuery is your huckleberry. So an example, aQuery. If you Bazel aQuery for my CC target, it's going to give you something like this. It's going to give you, so if you run a Bazel command and you say Bazel build this thing, you're going to see this message like compiling whatever. That's actually the name of the action that is declared there, and so you can see that and how it relates to what is actually happening under the hood. It gives you the mnemonic. So this is just one of the actions, but there's a CPP compile action under my CC target. It gives you the target label, the configuration, the execution platform, all this stuff, inputs, outputs. Command line is very long for C++ stuff. So I would recommend, if you're doing an aQuery for something, you want to limit the scope as much as possible. Otherwise, you end up with a very nice fire hose in your terminal. So
That action is not the one that goes to the remote tag, right? That's not the thing.
Sorry?
Or is it that action? That's not the one that goes to the action.
Right, the action key is not the action digest. Yeah, that's the key in the Merkle tree, I believe. Yeah. So types of queries. aQuery doesn't have the full query syntax that you have for other queries, so you can't necessarily do some path and things like that. The things you use in aQuery are inputs, outputs, and mnemonic. So inputs is if you want to query for the inputs. Outputs is if you want to query for the outputs, and mnemonic, yeah, so on. You get it. The parameters or the attributes you supply to the aQuery function or to the query language is on the left you give it a regex for the thing that you're looking for, and then on the right you give it the scope. So how much of the dependency tree or which target you're concerned about that you're looking for. So pretty straightforward there. And then finally, if you're confused about the word mnemonic and how we're using it here, this is the Bazel definition. If you don't like it, this was straight out of the Google or the Bazel doc, so blame Google. So the basically the way to think about this is just the human readable string that defines the thing that's actually happening when you run that command. So CPP link, it's linking C++ stuff. Scala compile, it's compiling Scala stuff. Java compile is compiling Java stuff. You get it. So yeah. Further reading, there's the cquery and aquery doc pages. Feel free to go read those. Peer into the abyss. And then finally, we're gonna do this. I may do this one together if that's cool with y'all, just to kind of look at it together. Yeah. So what we're gonna do is play around with that. The stuff that we just did, right? These configurations that we did. So readme, refresh preview. Feel free to play along at home if you feel like you know this stuff already. What we're going to do is run the queries we need to answer these questions. So question number 1 is, what is the output of a standard query for the first level dependencies of the flight data general? So if I Bazel query depths of Python tests flight data. What I'm doing is I'm passing it a 1 because I only care about the direct dependencies. And then I do no implicit depths. Then this is what it gives me. It gives me the flight data general, and it gives me the extended and the short, right? So this is exactly what we talked about earlier in the example that I showed you. If you just query for the depths on something that has a select statement, it's going to give you everything. So now, if I cquery for that information, option is not, wait, there we go. There we go. Okay, cool. So I cqueried for that information, and it gives me build CI. So it's like, hey, it's actually evaluating this configuration. And then it also gives me only flight data short. That's a new one for me. It doesn't normally do that. Never had this happen to me before. Okay, so now let's twiddle our flag. Build extended test equals true. All right, we do this, and you can see that it's using the flight data extended.json. The other thing you'll notice is that the configurations here are different, right? I have one configuration string here, and I have a different one here. And so if I Bazel config that, it dumps all that information. And you can see at the bottom here that it also has an information about that flag that I set, right? So I guess to that earlier question, the transition I don't think will show, but it might show the transition target, but it will definitely show you the things that came out of the transition if there are configurations that were affected by that transition. Cool. All right, now next one. What is the mnemonic of the action that produces the flight server executable? How do I do that? Yeah, okay, so we're going to Bazel aQuery. Whoop. Come on. There we go. Okay, what are we going to aQuery for? Huh?
Flight server C++
Um,
CC binary.
yeah, it's a CC binary. Huh?
Or Go. Flight server target.
Yeah, okay, so we can. So. Sorry?
The function, the mnemonic.
You want to use the mnemonic function? Okay. Okay. Star, comma, and then this is CPP flight server. Is that right? Doesn't like that. Oh. Yeah, yeah.
And yeah.
Okay, so I'm going to do dot star because that's how you do regex, and then quote it. And we get stuff. So there's a middleman mnemonic, symlink tree mnemonic, source symlink manifest mnemonic, repo mapping manifest. There's a lot of this. This is more than I wanted. Which one produces the output file that I want?
Maybe do it on a filter on the output of client server.
Yeah, that's a good idea. So we could do outputs. Do we want to do like star flight server? Like that, maybe? What did I do wrong? Sorry, say it again. Output. Oh, outputs. Okay, there we go. I only got one answer. It's a CPP link. So the thing that actually produces the binaries is this link in C++, apparently. Cool. Okay. Now, query for the CPP compile mnemonic for CPP hello. Okay, so that's easy. Bazel a query mnemonic. So CPP compile. And then we're doing CPP hello. Okay. So that's that action, right? Now do it with this flag. Whoop. This flag. Okay. Okay, so we did it with that flag. What differences do we notice? So I'm going to expand this a little bit so we can see both of them. All right, what do we see different about these two actions? Yeah, action key is different. Hmm?
The environment path.
Yeah, exactly. So what does that imply about that flag?
It changes the flag.
Yes, it does. It does. Yeah. The actual answer is that the strict action env says, okay, if you don't supply any environment, I'm going to supply default for you, right? And so in other words, if you don't use that flag, then your local environment is going to leak into your build. So, yeah, cool. That's I guess a little preview of some stuff that you can start to do to sort of understand how Bazel's reasoning about these things. Cool. Any questions on all this?
Can you use the strict action flag with current command, or is it just plain query?
That flag is a generic Bazel flag that I believe works in all settings.
Commands?
Yeah.
I think you can set it in the Bazel RC column.
Yeah, that's actually what I have. If you look at the Bazel RC for this, it's set to true, and that's why when you turn it to false, it suddenly removes the environment.
That's a common best practice.
Yeah, I would say so. We generally recommend it, especially for remote execution, and it protects hermeticity. Of course, you can take you can live dangerously if you like. Maybe if you have very strict control over your container or something like that, you would lean into that strategy. Maybe you don't have to worry about it as much, but I think in general, it's the safest thing to do. Cool. How are we doing on time? We have until 4. Okay. So platforms and tool chains available in the full session. Sorry, not doing that here. Clearly don't have time for that. Do you need a break? You could use a break. Yeah, let's do a 5-minute break, and then we'll run through these last 2 sections because these are where the real fun begins. I keep saying that, but it really is fun this time. First, I want to talk a little bit about the architecture of the Bazel client-server relationship. This, you probably were somewhat aware of this, but I want to make it really concrete because it's kind of interesting to kind of think about in general, but also it'll play into what we're doing in a little bit. So when you run a Bazel command, it's not like you spawn a single thread and then that does all of this stuff directly. What's actually happening is Bazel client will launch first and then see if there's a Bazel server running. And the Bazel server, if it's not running, it'll start one. And then the CLI, the thing that you type into to send Bazel commands, it's telling the server what to do via gRPC. And the server is kind of in charge of everything. It's in charge of the workspace. It's in charge of cache results on the local. And it's also in charge of spawning the workers, which are also separate threads that will spawn on different CPUs, right? So the Bazel server is like this daemon process that gets auto-launched for you in the background and auto-handles for you. And it's this nice transparent process. But you should know that when you run Bazel commands in your workspace, that it is launching a process that sits there for a while. If you've used it for a while, you're probably aware of this, but just know that this is something that's happening, right? So for the Bazel server, most of it, everything runs on a persistent server. There's one for each workspace, right? So if you look at your output base for any 2 workspaces that you have on disk, you'll notice that they're in different directories, and you can go and look and see that the hash directory is different for each of your workspaces. What this means is that there's 2 different daemons that are actually running at the same time. So you can kind of blow up your computer or, really run into memory problems if you're launching a bunch of workspaces on your computer at the same time. So again, be aware of that. The reason that the workspace or that the Bazel daemon runs in the background and stays up is to keep your analysis warm, right? It keeps the Merkle tree, your analysis, other information about the builds kind of in memory. It builds it the first time in analysis, and then it keeps it around. And so that way, when something changes, you can just calculate the diff instead of having to regenerate the entire analysis or recalculate hashes and all that stuff. So it's kind of around to optimize and to make sure that you're not spending forever in analysis, ad nauseum. Some flags affect the server. You probably have seen this before, but there might be a message that says like, different configuration detected, analysis discarded. That just means some flag was detected that affects analysis and how it calculates analysis. And Bazel decides, you know what, I give up on the analysis on this. I'm just going to redo the entire analysis. And so the reason that's painful is because it does it once and kind of saves it for you, right? And so that's the daemon in effect. That's the nice thing about it. And it's also local to the execution host. If you're familiar with remote execution, that's a totally different concept. When we say server here, it really just means like a daemon process that runs on your local machine. And then if you're doing remote execution, that local server is talking via gRPC to the remote execution service that you're using, like EngFlow, for instance. Bazel command execution. I said this earlier. The client sends commands to the server or the daemon via gRPC. There's a locking mechanism in place. So for each daemon, it kind of only makes sure that it's like if you try to run a command and then you launch a different terminal and then you run another command on the same daemon at the same time, it's going to say, hey, hold on, buddy. I'm still running something over here. So it doesn't let you run multiple commands at the same time on the same daemon. You can, however, accidentally run commands on 2 different daemons, so watch out for that. Parallelism, if you're not aware, there's a -j flag or -- jobs that handles the parallelism for Bazel. So by default, it will launch the number of the jobs number will be the number of CPUs or cores that you have on your system. So if you're in a 16 core system, then by default the -j value will be 16, which means that Bazel can start up to 16 worker processes that will all run at the same time. So if you're on a language like Scala, for instance, that's on an older version, you don't usually get parallelism or multi-threading out of the box with it, but you can with Bazel because it will launch 16 different Scala C actions all at the same time, and they can all compile at the same time, and you get kind of like a nice sort of multi-threaded that's very basic out of the box there. The other fun thing about the jobs value, it's really fun to kind of figure out what the default value is for the jobs because the documentation does not tell you. And if you go on Google for this, you'll eventually find a GitHub post where somebody from Google says, we did this on purpose. The jobs value when I started learning Bazel was actually the number of cores divided by 2. They changed it later to the number of cores exactly, or like close to the number of cores. And they said, basically, we're reserving the right to kind of change this as we sort of go, but the number of jobs is sort of in flux, so we purposefully leave it out of the documentation. So caveat enter there. Yeah.
Is there any authentication between the server and the client?
On the local machine, your local.
If I'm running in a remote execution,
There are a couple of authentication schemes that are supported by Bazel if you're using remote execution. Yes.
I use build barn, so I don't.
I don't know offhand. So I'm not a build barn expert, unfortunately. I work for EngFlow, so I know what EngFlow does. But I know that, for instance, like there's Bazel does support MTLS, so EngFlow supports MTLS. Bazel supports JDBT tokens, and so EngFlow supports JDBT. And then there's also like an auth helper. So you can configuration set an auth helper to run a command to do auth, and we support that as well. So you can use like an auth config to log in.
Do that in build barn as well. There's a version for the process controls.
Cool. Okay, cool. Yeah, I did not know that. So
I got a question.
yeah, sure.
When you like run a fully cached build, so assume you're not building anything, just get cache bits. Jobs is an effective limiter of concurrency of checking things in the cache. As in, every executor is checking the actual cache.
Yes, there's a later on. There's a slide where we say you have to set the jobs number up if you want to do remote execution, because it will limit your concurrency. Because it so essentially, yes, if you're using remote execution or remote cache, you probably want to set the jobs number up. Usually, what EngFlow recommends is like you can set the jobs number up to 200 or in the low hundreds, and that will increase your parallelism quite a bit on the remote executors, and it doesn't tend to overload. And you can we'll look at this in a minute, but you can look at profiles if you suspect that there's locking in your local. You'll see like a bunch of really long semaphores, acquiring semaphores or whatever. So it's a really tricky balance. It really depends on your build graph, but yeah, you can kind of play around with the jobs level if you want. Command execution, each invocation gets a unique ID. So there's a UUID that's generated. You can set it if you want to, but it's a UUID. Just take whatever Bazel throws at you as the default. This is the slide that I was talking about. So each action takes finite resources, may spawn other commands. Use the jobs parameter to manipulate it. Number of cores on the host by default. I've already said all this, I think. Yeah. So yeah, cool. Yeah, we talked about this. Great.
Actually, is there a way to like change the maximum parallelism for checking over AC cache and actual execution? So like, if I have everything in cache, I would love to go to the cache as soon as possible. But if let's say I don't want to execute 1,000 actions at the same time because maybe I want to be conservative with my executor. Is there a way to do that?
So the question was, can you limit the jobs number for specific types of commands or things?
Can you like limit the amount of executed actions versus parallelism when you're going through an actual cache, just checking for cache?
I don't know of a good way to do that. A way that you can consider it maybe is if you want to set the jobs level to different levels for different commands or different mnemonics. But that won't help you really for only doing remote cache check things. So, but yeah, I don't. Yeah, that's a really interesting question though. I like it.
There are some like max connection limit flags.
Yeah, I know.
And so like, but I don't know how they interact with jobs.
Mhm.
Right? That'd be interesting.
There's also, if you really want to muck around with parallelism, there's an experimental flag, and I don't have it in the slides or in my memory because I just Google for it. But there's a flag that you can tell it to essentially use Loom as the virtual threading instead of using actual threads. So there's less semaphore stuff, but then you're sort of at the mercy of the JDK, which could be good or bad. Loom is pretty good from what I hear. I have opinions about that too. That's probably shocking. Anyway, moving on. Let's talk about determinism again. Okay, so in this example, I've got a Python script, right? let's pretend for a minute that Bazel only knows about the things in the dotted line. Let's say there's an input.txt file, but it lives somewhere in your file system in a static location, and I'm just referencing it directly. And let's say that I'm also depending on Python 3 being in the path, and I don't reference it directly. I'm not hermetic at all, you know. So let's look at what would happen if Bazel only knew about that Python script. So question number 1 for you is, let's say I change that input file. What would happen to my build? No, I did not declare it as an input file. It's like my Python script is really naughty, and it's looking for it in a hard-coded space, like a hard-coded path.
If you have normal cache, then nothing will change. If you're cached, you won't read on it.
Yeah, exactly. Right. So like because Bazel's not aware of my input file, it's going to not take it as an input consideration. So the action cache key for the Python script will not change. So if I run it twice, I might get a cache result, but then if I delete my cache and then run it again, I'll get a different result. So what happens if Python 3 is not installed on the system? Let's say I install it. I have a Python 3 hard-coded installed. Totally not a real-world example. And then I give it to somebody else, and they try to run the script. What happens if they don't have Python 3 installed at the same exact place? Huh? Yeah, exactly. So it's effectively flaky, right? Like it might get a cache hit and succeed. It might not and then fail. So let's talk about sandboxing a little bit. Bazel has this strategy for like trying to make sure that you have all of your files in the right place, and it's called the sandbox. And you can totally do really naughty things and break all of this. And so sandboxing gives you different strategies to kind of try and discover this if you want, right? So in general, the way to think about this is that Bazel by default will put things in a sandbox to isolate execution between different processes, between the different worker threads that are running. And the way that it sort of does this is it kind of like creates this symlink tree for your action, like in a specific location. And then it will run everything, all the commands from that specific sandbox location. So if you don't declare your inputs, it won't symlink them into the sandbox. And that can be a way that you might end up with things sort of failing. You can think of it kind of like a clean room strategy for making sure that you've got all your stuff declared. If you want to change the sandbox strategy, you can set spawn strategy, and that will change things a little bit. So the spawn strategy, the different options you got, there's sandbox, which is the default, which is I just want to execute everything inside the default file system sandbox, which is a little bit different depending on if you're on Windows or Mac or Linux, but roughly the same. Local is like I just want you to run it in place, like in the output base or whatever. Like I don't want you to copy it into a sandbox. I want to be as performant as possible and like throw caution to the wind as far as sandboxing goes. If you set it to worker, you can do it using a persistent worker if available. I'll talk about that in a minute. If you want to go full ham, like I want to discover all of my warts, all of my problems, then you can set the spawn strategy to Docker, and that will execute. You will create a sandbox inside a whole Docker container for every action. So that's like I want to fully protect myself from thinking that from anything that's on my local file system or my local path. And then finally, like the end of this, like I think the most parallel you can get and the most protected you can get is with remote execution, which is inside a Docker container on a remote executor. So like nothing is on your local computer; it's fully uploading onto some environment up on the cloud, like EngFlow. So persistent workers. Some actions can naively spawn new workers and new processes. So if you're in a C++ compile, it makes sense to just run the command with a new worker every time, right? Because the new worker is not doing anything particularly interesting. Like you just kick it out to a new thread. The new thread runs CPP link or CPP compile or whatever, and it's fine. It doesn't need anything. But if you're doing something with Java, for instance, you might if you do Scala C for every single action naively in a new thread that gets destroyed immediately afterwards, what happens is every thread has to spin up a new JDK. Like it has to warm up a new JVM and then do the compile, and that can be pretty costly. And so that's where persistent workers come into the mix. The idea is that instead of terminating the worker process, it will keep that worker process around and then just ship it the new action inputs and tell it to run the command again, and we'll use the same environment. Obviously, if you do this, you have some concerns about, inputs and JVM things bleeding across actions, and then also the default behavior in persistent workers is not to sandbox, and so you have to set worker sandboxing if you want the persistent workers to run inside sandboxes. The way that you typically do this, so there's a couple of ways you can set the strategy. One of them is if you do -- strategy equals, and then you pass it a mnemonic, and then you say equals worker, that will limit the spawn strategy for only the mnemonic. So a common thing that you might say is like -- strategy equals Java compile equals worker, right? Just an example. Debugging the sandbox. So there's a couple of flags that are pretty useful. Use these cautiously. I'll go into that in a second. But -- sandbox debug will preserve the sandbox. I said earlier that the sandbox gets deleted after every action. -- sandbox debug tells it not to delete those directories. Useful for forensics, so if you're trying to figure out, okay, what's going on in my actual sandbox? I don't know what's going on there. It does fill your hard drive very rapidly because it doesn't delete anything, and so use it sparingly. I prefer to only do sandbox debug for a specific target. That way, only the actions related to that target get run. So you can kind of limit the blast radius here because it will fill up your hard drive very quickly. And then the other thing, sorry.
Is that clean for the Bazel clean, or is that like separate? Preserved.
I believe it is, but I'm not sure offhand. Huh? Oh yeah. So yeah, that's if you expunge, it will wipe the output base. So, and all those caches. Yeah. I'll show you in a second where the sandboxes actually live, so you can kind of check on it yourself and kind of see. And then the other thing you can do is verbose failures. So what this does is it shows the command that was executed that fails. Again, if you do this for everything all the time, then you're going to get like a lot of noise in your CI. I don't recommend doing it all the time. But the combination of sandbox, debug, and verbose failures is really great locally because what it does is it gives you the exact command, which includes the exact sandbox that failed, and then you can go and CD to it and then see what was in that sandbox. So the combination is really powerful. So where does your sandbox live? This is a kind of a little section that I took out from before where we talk about the different file system paths. But what you can see here is like on a Linux system, the output base is home user cache Bazel user, and then there's this hash here. That's your output base right there, right? And that's a different hash for every Bazel workspace. And then under your output base, there's going to be a sandbox directory. And under your sandbox directory, there's going to be a configuration. So, and then after that, there's going to be a number, a numerical ID. And that numerical ID is per action, right? And so if you build the whole world and turn on sandbox debug, you're going to see like thousands of directories, and you're not going to know which one is the one that you want. Which is why the verbose is super interesting. Yeah, so further reading, you can visit these links if you want to know more. There's a whole lot here about spawn strategies and sandboxing and things like that. And so pretty useful stuff. But let's go, let's spend some time attacking the sandbox for a minute. Oh, we're running really low on time. Maybe what I will do is I'll just quickly do this lab with y'all. And then we can go through the slides on the last bit. And then there's some pretty interesting stuff that happens with the last exercise. Yeah, yeah, I'll get there in a second. Okay, so in this exercise, what we're doing is using sandbox debug to analyze a common issue with determinism and input files. In SH, you will notice new files and targets. So what I've done here is in SH, there's a find flight.sh, which uses JQ to essentially query the flight data, and then there's a gen rule that produces that output of that information there, right? So yeah, so here, yeah, sh get flight status is a general that runs this script, and it queries for the data on flight number 4. So like if we look at that general, it calls get flight status. It calls find flight, which is my new shell script. And it calls it with a value of 4 and then dumps it to an output file, because that's what general does, produces output files. And so 4 status.txt is going to have like the result of JQ for the flight number 4. So let's kind of verify what's going on here, right? So I'm gonna run find flight 4, and this is the output. This is what JQ does with this command. Is it queries that large input file and produces the flight information for flight number 4, right? I could do this for the other flights too if I wanted to. 7, yeah, and it produces different information, right? Okay, now let's build get flight status. So get flight status is my general that runs that command. Okay, so if I, oh, sorry. Okay, it failed, of course, because we're debugging something. And what it tells me is executing this general failed. Error executing general. Error data file flight data extended.json not found. So I can't find my input file for that flight data, right? So why does it fail? Any thoughts? Let's sandbox debug to find out. So I'm gonna dash sandbox debug and dash verbose failures. And I get, so here's what I was talking about earlier. So you can see it does a CD to this directory. The sandbox directory is this, right? So I'm going to do that in a new terminal. CD boop. Okay, so it goes to exec roots, main. Okay, so let's go to sh first. And you can see in my shell script directory, there's findflight.sh in my sandbox. That's what's there. But it does not have flight data extended. Flight data extended is in this directory, but it's not there in my sandbox. So why is it, that is why it can't find the files, because it's not in the sandbox, right? I can see it in the sandbox. I can see it's not in the sandbox. So what do I do to put it in the sandbox? Any ideas? Yeah, exactly. This is, I think I ran into this exact problem the first time I tried to write a shell script with Bazel. A rule to run a shell script in Bazel. So yeah, this was my not so gentle introduction into build into the sandbox. So here I'm just gonna data equals, this would be flight, well, I don't have to have that. Data extended JSON. Okay. And then I'm going to go back to this terminal and Bazel build it again. And sorry? No, oh, no attribute data. Huh? Sources. Okay. Ah, there we go. Cool. Yeah. So yeah, that was it. General needs sources, not data. And adding it to that, if I go back to, well, if I do sandbox debug again on this, of course not going to give me a failure message, but if I Oh, well, it's moved it around on me. Anyway, if we were to go and look at the sandbox for this, you would see that it did in fact keep that. It did in fact move the JSON file into the sandbox. So that was our whole problem. So this is obviously a very small contrived example, but in actuality, when you have files missing, sandbox debug is a way that you can start to see that. It's really useful for tool chain resolution, debugging that, because it's very often the case that like maybe you're missing a .o file somewhere and you're not expecting it to be missing, and you need to go and look and figure out what's going on. And so in those cases, having sandbox debug can really help you exactly figure out all of the stuff that's in the sandbox, so you can debug those situations a lot better. Okay, we are really low on time, so I'm going to go over the slides here, and then I'll talk about the exercise and tell you kind of what to look for, because there's a really fun little trap in there. Okay, so there's this whole section is about all of the different kinds of log files that you can and profiles you can dump out of Bazel that are super useful for varying situations. The first is an execution log. Execution log has all of the action details, input and output hashes. So you can kind of think of it as like, what if I queried everything in my build tree for a particular invocation, but I didn't want to like look at it all in the terminal, I just wanted to dump it to a file. Then execution log kind of gives you that. It gives you a lot of that action detail, a lot of the input files, output files, mnemonics. It gives you the action cache digests, things like that. So it's pretty useful for debugging hermeticity issues and determinism issues. There's 3 different formats. There's compact file, which is a zipped proto file. There's the binary file, which is just a proto file. And then there's a JSON file, which is the raw human readable. I would say if you're debugging something locally, JSON file is okay, but if you're dumping these on the regular basis in your CI, then you want to go for compact file. In fact, EngFlow if you do the compact file, EngFlow takes those and uses it for action cache debugging. Execution log, typically I just said this, typical action, if you want to debug action re-execution causes, determinism issues, you suspect something is leaking a timestamp into a general, then exec log is where you want to do that. There is a post here on the Bazel docs that tells you how to do this exactly. Essentially, all you do is you set that to a static location. You do a build, you do a Bazel clean, you do the build again. Yeah, and that gives you the information. If your exec log is empty, that means it was all cache hits. Bazel profiles. So in addition to the exec logs, you can also dump out Bazel profiles. That is it essentially generates like flame graph Chrome trace compatible files that you can drop in, and it gives you a per section of an action breakdown of everything that's happening. I mentioned earlier, like if you set your job level too high, then there's a thing that happens in Bazel where it uses a semaphore to manage the actual usage of different actions. And if Bazel's taking a really long time to acquire semaphore, that'll show up in a Bazel profile. So you can say, oh, my job number is too high, it's trying to do too many things multi-threaded. If it's taking a really long time to upload inputs or download outputs, if it's all just execution time, you can get all of that information out in the Bazel profiles. By default, it keeps 5 around. So for the last 5 invocations you have, you can go look in the output base and see those. The invocation ID is how you can see them. You use -- profile to change the JSON profile location. And then you can disable or enable that with this flag. The what? Exec log and the Bazel profile? I would say the difference is like the exec log is like if you want the information about the input, like query information about inputs, outputs, the actions that were run, action digests, but it doesn't give you like all the runtime information. It's just like, I ran this action and here's all the stuff about it. And so that's what that's useful for. The profiles are really for performance tuning and understanding where all the time went in your builds. So it's like a Chrome trace of like all this stuff. I'll show you what it looks like to analyze the Bazel profile in just a second. If you go to Chrome tracing in your UI, you can drag and drop your profile there and see it locally. There's also Perfetto, ui.perfetto.dev, that's open source. You can host it yourself or you can upload it to that site. The EngFlow has an analyzer that is built into the UI, but it's also available open source. So you can drag it onto EngFlow and see like, EngFlow's recommendations about, hey, your job level is too low. You could really make this faster if you increase it to like 50, things like that. Also, if you do use EngFlow, our UI page by default gives you access to the Bazel profile through Perfetto, and also gives you access to the EngFlow analyzer, so you can do all of that and see what it looks like. I'm not going to talk about Skyframe. All the threads, all of your worker threads say Skyframe. That's what that slide is about.
So another question I have is, usually when you have an action that's non-deterministic, it has undeterministic outputs, and you use remote cache, you're not going to catch those non-deterministic outputs because everything is served with a cache. So I wonder if you have any tips for debugging this kind of things, because obviously you can run with no remote access cache, which is going to run everything. I was wondering if there's like some kind of better, more targeted way to.
Okay. So what's really funny is the exercise, the way that I designed the exercise, I did it without disk cache, and you could see it clearly. And then I turned disk cache on as an optimization later and ran into this exact issue. And it was so fun, I left it in as a trap for people to run into. And so the short answer is, if you have remote cache, yeah, it will disguise this. And if you do a Bazel clean expunge, it'll still disguise it. You'll tear your hair out. You're like, what's going on? So thing number one you can do is you probably want to turn off disk cache. You want to turn off remote cache if you're looking for this specific scenario, because that's the only way you'll see it. The other thing you can do is, I don't know about Build Barn, but I know of like EngFlow, for instance. If you use EngFlow and you have two different actions that you suspect have different inputs or non-determinism in them, you can actually inspect per action the hashes for every input file.
Yeah.
And so that's another way that you can kind of look at it.
Because like, if you rerun the whole build, like for me, like rerunning the whole thing can take like hours. So
Yeah.
I was wondering if like maybe that's like a feature request for Bazel to like able to rerun just like a portion, like like a subtree.
Well, you can. You just tell it not to build the whole tree. You tell it to Bazel build only a target, and then it only builds that target, right? Yeah, exactly. You can also tell targets not to cache. This is what Perfetto looks like. The stuff at the top is like garbage collection information. So if you don't have enough RAM in your Bazel daemon, that'll tell you, like it'll have giant garbage collection threads. Critical path info. The other thing that's really cool is if you zoom in on these, you can see the per action stuff that I was talking about. So like you can see the execution time, the download time. This little bar at the front is the semaphore time. If you see it like your entire build is dominated by semaphore time, you probably want to turn your jobs level down, stuff like that. And then at the bottom, you can see like for your Bazel daemon on your CI system or your local machine, you can see CPU, memory, input, output. So if you're trying to optimize your CI runner, then the Perfetto view is really great for that. The Bazel profile gives you all that data. This is the EngFlow analyzer. This is what shows you like, hey, you need to use more cores, or hey, you should use remote execution with EngFlow. Haha, hint, hint. So this is pretty useful. It is actually really useful, and it is open source. And so like we do give you information about flags you should use or things you could do to tweak your builds. I jest, but it actually is quite useful for those sorts of things. And then finally, the lab. I guess I'll leave it for you to do as exercise for the reader. All it does is it gives you a couple of ways to generate some invocations and play around with it and inspect the inputs to kind of experience these problems. I apologize that we don't have time to do this together, but this is probably the most interesting lab. So do go find some time to do this lab. Ping me if you run into problems. Any final questions? Yeah.
What do you think about the remote gRPC log?
The remote gRPC log is not in the slides, but it is pretty cool. It is specifically if you're trying to debug issues with your remote execution platform. So let's say, for instance, you suspect that Build Barn is holding on to weird state, or you get like a missing digest error, and you're like, why is that digest missing? The gRPC log is the full log of every gRPC request and response to and from Bazel, your daemon, and your remote execution, remote cache platform, so you can exactly debug exactly what the state was for your remote system and your local. So that's another really useful one. It's also in the 3 formats, the compact and JSON and whatever. So exactly, yeah. So you can, yeah. So okay. Well, thanks so much for your time, guys. It's been great.